All right, sector OAB is a quarter circle with radius 3 centimeters. And a circle is drawn inside this sector tangent at the 3 points shown. Okay, so it's tangent here and tangent here and tangent here. Okay. What is the radius in centimeters of the inscribed circle? Express your answer in simplest radical form. All right, well, let's draw in this radius that we're trying to find, okay? And it's often a good idea to draw in the radius to the tangent points, okay? So that's something to remember if you're working on these types of problems. So let's draw in the radii to the tangent points, okay? So this is going to be length r, this is going to be length r. I'm just going to call it r. That's what we're trying to find, but I don't know what it is, so I'm going to call it r, okay? And you can see that down here in this lower right hand corner we have a square, okay, because we know this is 90 degrees, okay, and this is 90 degrees, so we have this square down here, okay. So really the key to this one is to figure out the diagonal of the square, okay. Now we could draw our diagonal across here, or actually what would be even better would be to draw the diagonal here, okay, because you can see that if we know the length of the diagonal and then we're going to add r to it, it's going to be the radius of this quarter circle, okay, and the diagonals are going to be the same no matter which way you draw them because it's a square, okay. So this length is r and this length is r. And the length of the diagonal here we can figure out by the Pythagorean theorem, because r squared plus r squared is equal to 2r squared, and that's equal to the length of the diagonal. I'm going to call it d squared. Okay, so essentially d will be equal to r times the square root of 2. All right, so we can add r plus r times the square root of 2, and that's going to be equal to 3, okay, because we're given the radius of the quarter circle. So let's solve for r. Let's factor out an r here, and we'll get 1 plus the square root of 2 is equal to 3. And then we'll divide both sides by 1 plus the square root of 2, so we get r is equal to 3 over 1 plus the square root of 2. And if you got this, you're doing very well. You know, some people might not know what simplest radical form means, but essentially we just want to get the radicals out of the denominator. All right. So there's a little trick for getting the radical off the denominator. So if we had something like let's say 1 over the square root of 2. All right, we just multiply by the square root of 2 over the square root of 2, and we end up with square root of 2 over 2. Okay, what we want to do is multiply by something. It'll be a 1. It'll be a 1, but it'll be a special 1. So that we can get the denominator to be a rational number or an integer. Okay, be nice to have that as a rational number, and then we don't have any radicals in the denominator. Okay, so let's the trick is to multiply by the conjugate. Okay, and first of all, let me give you a little bit of background. There's a special factorization when you have the difference of two squares. You can factor that into a plus b times a minus b. Okay. So, and you can test that just by multiplying this out. You know, going backwards. If you take a plus b times a minus b, you end up with a squared. Okay, so we're just using the distributive property, or some of you might know the FOIL method, but but it's just based on the distributive property. Okay, so we're taking a plus b times each of these terms, so we'll get a squared plus ab, and then we'll get Okay, so I just multiplied a times both of these terms. Now I need to multiply the negative b. So we end up with negative ab, and we'll get minus b squared. Okay, so you can see these two terms cancel out, and we're left with a squared minus b squared. Okay, so if anytime you see the difference of two squares, you can automatically factor it into a plus b times a minus b. So we can also use this this factorization to get the radical off the bottom, because you can see if we squared 1 and squared square root of 2, then that would be good. So the conjugate of 1 plus the square root of 2 is 1 minus the square root of 2. And if we take 1 minus the square root of 2 over 1 minus the square root of 2, that's just 1. And multiplying by 1 doesn't change the answer. Okay, it just changes the form of the answer. And you can see that here we have 1 plus the square root of 2 times 1 minus the square root of 2. So it's in this form, a plus b times a minus b. So we're going to get, in the denominator down here, we're going to get 1 minus 2. Okay, so that's negative 1. And then on the top, we'll get 3 minus 3 square root of 2. Now this is going to be negative 1, and it'll end up being, dividing by negative 1 is the same as multiplying by negative 1. So we can actually just switch these terms around. 3 square root of 2 minus 3. Okay? So in simplest radical form, that's the answer. It's 3 square root of 2 minus 3. Okay? And that just is, we just got the radicals out of the denominator by multiplying by the conjugate. And then if we take the conjugate over the conjugate, that's just 1. So we haven't changed the value of the result at all. Okay, we've just changed the form of the result. So there you go. That was a little tricky just because it required you to knowing about how to get the answer in simplest radical form.